Hello, and thanks for using TickBoom, a free service that helps high school students with their math problems. A student has sent through a question which comes from the 2019 3 unit or extension 1 preliminary exam from James Ruse. And the question reads, if sine theta on 1 plus cos theta plus sine theta on 1 minus cos theta equals 4, find the exact value of cot 2 theta, and we're given the domain of theta being between 0 and pi on 2. So to start, I'll just write up what we're dealing with. So we've got sine theta on 1 plus cos theta plus sine theta on 1 minus cos theta equals 4. And we want to find the cot of 2 theta for the domain theta between 0 and pi on 2. And this cot theta, we want the exact value, so it's not going to be a matter of throwing things in the calculator necessarily. We're going to want the exact value, so that there's probably going to be a third in there somewhere. I think to get started with this, we should try and simplify this left-hand side and see if we can solve for theta. Seeing something like 1 plus and 1 minus kind of makes me think we're going to get a difference of 2 squares. And if we've got cos squared theta in the mix and we end up with something like 1 minus cos squared theta, that'll become sine theta, so we should get some simplifying happening. So what I might do is I'll just bring the sine theta out the front, because we've got sine theta in both of these fractions. And that would then leave us with 1 on 1 plus cos theta plus 1 on 1 minus cos theta, and that's equal to 4. And then I think if we get this common denominator in these fractions, we'll end up with a difference of 2 squares. So that will become sine theta, and in the denominator we're going to have 1 plus cos theta times 1 minus cos theta, and to get there we need to bring each of these up, so we'll have 1 minus cos theta plus 1 plus cos theta in the numerator, and that's all equal to 4 still. This minus cos theta and plus cos theta will cancel, and so this will then become sine theta times the 1 plus 1 in the numerator becomes 2, and 1 plus cos theta, 1 minus cos theta is a difference of 2 squares, so it will be 1 minus cos squared theta, and that's still equal to 4. Now, because sine squared theta plus cos squared theta equals 1, that kind of classic identity, we know that 1 minus cos squared theta is sine squared theta. So then this becomes 2 sine theta on sine squared theta equals 4. The sine theta and one of the sines in the denominator cancel. And if I bring the sine theta that's remaining up, we'd get 2 is equal to 4 sine theta. And if I just reverse these and bring sine theta by itself, we get sine theta equals 2 on 4, or a half. And at this point, it's probably helpful to perhaps, just over here, I'll draw a kind of classic right-angled triangle. One that's kind of often committed to memory, or sometimes even provided in a cheat sheet on the exam. You see the triangle 90, 60, 30, and the side lengths are 1 to root 3. And from there we can kind of see, if we remember our SOHCAHTOA, for sine opposite on hypotenuse, if we pick this 30, we get opposite on hypotenuse would be a half. So we can kind of conclude from there that theta would be 30 degrees. And, you know, you could also just get your calculator out if you're a bit worried that you didn't remember this triangle right, and you could do the inverse sine over half is 30 degrees. And actually another check you could do, and maybe I'll just do it up here. If we wanted to really be comfortable that this is the correct angle, we could just put it back up into our original equation. So on our calculator we could check sine 30 on 1 plus cos 30 plus sine 30 on 1 minus cos 30. What is that equal to? Hopefully it's equal to 4, but let's check in our calculator. So sine 30 divided by 1 plus cos 30 plus sine 30 divided by 1 minus cos 30 is 4. So that's also a good check to do. Very comfortable that theta is 30. And we can also be confident that that's the only solution for theta we need to think about. If I just draw up a little diagram of the sine curve, so I'll just do this for up to 2 pi, so we'll go pi, 2 pi, and I'll call this 1, 0, negative 1, so pi, 2 pi. So the sine curve looks like this. And we're concerned with when it's equal to a half, so if I just kind of dot that in, you can see there's going to be multiple times where the sine curve intersects with a half, but because our domain, we're told, is theta between 0 and pi on 2, so kind of we're really concerned with this part of the domain here. There's only the one solution for theta there, being this 30 degrees that we just found. So that gives us the comfort that we don't need to worry about other values of theta. This is the one value that we can proceed with. So now we can get to what we're really wanting to work out, which is cot of 2 theta. So what we can say is cot of 2 theta would be cot of 60, because 2 times 30 is 60. Cot by definition will be 1 on 10. So we're going to have 1 on 10 of 60. And using our SOHCAHTOA here, tan of 60 would be the opposite over the adjacent. So it would be 1 on root 3 on 1, which is simply 1 on root 3. And we can stop there because the question asked us for the exact value of cot 2 theta. So here we have it in insert form, and there's no need to plug it into the calculator. Boom! So that's how you do that question. If you found that explanation helpful, please be sure to give it a like. And if you're someone who wants to keep their finger on the pulse with the kinds of questions that other students are struggling with, please be sure to subscribe to my channel so that you can stay in the loop. Alright, tick boom.